end of the Test Yourself 11 video on coordinate geometry. So, copy the diagram and using the same scale on the x and y axis, draw lines through A with the slope 1/2 and -2. Now we don't know what A is, okay, so we have no idea about the slope of A, okay, but what we can do is we can just make our own slope over here using a grid, okay. So we'll just 1 second on this. Okay, so what I'm going to do is just going to copy this diagram, okay, and instead of so I'm just going to copy this diagram and replicate where A is, okay. So here is your x and y axis as shown above, and as you can see A is just maybe across one up a couple, so we'll just figure our point A. So give our point A somewhere up here, okay. Now what we can do is we're looking for a line of slope 1/2, okay. Now remember, slope equals rise over run. Rise over run. Now a slope of 1/2 is basically 1 for every 2 I go across, I go up 1. So do a slope through A using this rise over run technique. I can go up 2 and across 1, which would be here. Then all I got to do is just link these two points together, and I can get myself a slope of 1/2 quite easily. So all I do is just link these 2 points together. Now make sure when you do this that you do use a small dot, because sometimes the big dots can make an error like this. So use a small dot like so. Then all we're going to do is rotate this around, and this one here will be the slope of 1/2. So we can just shade this one in like so. There we go, there's the first line of slope 1/2. Okay. Now we're on the second line where we have to do a slope of -2. Now once again remember, for a slope of -2 the rise can be -2 and the run can be 1. So it drops down 2 and across 1. Okay, so I'm going to go to point A and go down 2 across 1. So down 2 across 1 will get me here. And then all I got to do once again is just rotate the ruler and draw a line through it that has a slope of -2. There we go there. So there's our 2 lines now drawn, okay. So there's the slope of 1/2 and slope of -2. Okay, so the next question is, the line AX plus Y plus 1 passes through the point A of intersection of the lines x equals 2 and the x-axis. Passes through the point of intersection of the lines x equals 2 and the x-axis. Find the value of A. So what we need to do here, we can just get rid of all this for a minute. Okay, and so we're going to reuse our graph from earlier, our chart here. Okay, and what we're going to do is we're going to draw out what we're looking at. Okay, so what we have here is our xy axis, and we can draw out our xy axis like so, and let a gap of 2 be worth 1 in this case. So that's 1, 2, 3, 4. This can be y equals 1, y equals 2, y equals 3, y equals 4, y equals 5. Now what we're asking this one is the line passes through the point of intersection of the lines x equals 2 and the x-axis. Well, this is the x-axis here, and the line x equals 2 is basically a line where all the points x value is 2. Just get rid of this for a sec. So what we can do next is we just want to draw a line straight through x equals 2. And this line is basically the line x equals 2. like so. And you can see where it intercepts the x-axis. It intercepts the x-axis at the point 2, 0. So this is the point 2, 0, because the x-axis is this line going across here. Now, we know that the line ax plus y plus 1 passes through this point. So this means the point 2, 0 is on this line. Okay? And if it's on the line, it makes a balance. So when we replace x with 2 and y with 0, the equation should balance. So what I'll have here is a times 2 plus 0 plus 1 equals 0. Bring the 1 over. Then we're going to get 2a equals minus 1. Bring the 2 underneath. A equals minus a half. Okay. Next question. Question 10. Find the equation of a straight line through 0, 1 and 3, 7. When we know 2 points, the equation of a line we need is y minus y1 equals m into x minus x1. And what we can do with this is we can say that this is x1, y1, x2, y2. So we can say that this is y minus 7. Okay, so we need to find the slope first. So we know what y1 is, and we know what x1 is, but we need to find what the slope m is. Now the slope formula in your maths tables is y2 minus y1 over x2 minus x1. So we can just simply get that one there. So we're going to get 7 minus 1 divided by 3 minus 0. That's going to be 6 over 3, which will give us 2. So we know the slope is 2. Now we can just multiply it out. So we're going to get 2 into x minus 0. And then we're going to get y minus 1. Multiply it out. Y minus 1 equals 2x. You can bring the 1 over to your side. Y equals 2x plus 1. Another line has the equation y equals 7 minus 2x. Without drawing the lines, explain how you can tell whether or not this line is perpendicular to the line in part 1. Okay, so to explain if two lines are perpendicular, what we generally use is y equals mx plus c. So what I'm going to do with the second equation is we're just going to put a line in between both of them, like so, and what we're going to do is we're going to rearrange the x's in front of the number there. So we're going to get y equals minus 2x plus 7, and this is still y equals 2x plus 1. Now we're going to write down y equals mx plus c underneath both of them. And what we can say is the slope of this line is 2. So, and the slope of the second line is minus 2. So the slope m1 and m2, the first slope is 2, the second slope is minus 2. Okay, they are not perpendicular. I believe it's asked me for perpendicular. It's not perpendicular. As the product of both slopes. Now what I mean by the product of both slopes is when you multiply them together. As the product of both slopes doesn't equal minus 1. So m1 multiplied by m2 does not equal minus 1. So 2 times minus 2 actually equals minus 4. So that's how we know they are not perpendicular. If they are perpendicular, they'd multiply to give you minus 1. So the perpendicular slope of 2 is minus a half. You turn it upside down, change the sign, and when you multiply them by each other, you should get minus 1. Okay guys, next one. The map below shows a part of a town containing a park and some streets. This is measured in kilometers, horizontally and vertically from the town hall. Town hall obviously being here, we'll call this 0, 0 obviously. And shown in coordinate form. How long is the path from B to C? So B is 310 and C is 10.9. So B to C. So to get how long it is, we need the distance formula, and the distance formula is the square root of x2 minus x1 squared minus plus y2 minus y1 squared. So we're just going to have to figure out which one's x1 and y1. So we call it x1 y1, x2 y2, and what we're going to get the distance is the square root of square root of 10 minus 3 squared plus 9 minus 10 squared. And all you gotta do then is just quickly put everything into the calculator. Square root of 10 minus 3. Just double check the calculator. 10 minus 3 squared plus bracket 9 minus 10 squared. Once again, just check that it's the correct numbers. And what we're going to get here is 5 root 2 or 7.07. So D equals 5 root 2 or 7.07. Okay, to 3 significant figures. Okay, so it's 7.07 kilometers, okay? But it says the word 3 significant figures. What is a significant figure? Well, we can go down the back. Right, a significant figure, in a significant figures, all 0 non-digits are considered to be significant. For example, 91 has 2 significant figures, 9 and 1, while 123.45 has 5 significant figures, as in 1, 2, 3, 4, 5. Zeros appearing anywhere between 2 non-zero digits are significant. For example, in the 101, the 0 counts as a significant number, and in 0.203, this 0 also is a significant number, so this one has 7 significant figures. Leading zeros are not significant. For example, if we had 0.00052, it only counts as 2 significant figures because the zeros are leading. Okay? Now, trailing zeros in a number containing decimal point are significant. For example, 12.2300 has 6 significant figures. The number 0.001222300 still only has 6 significant figures because the zeros in front aren't considered significant. Okay. In addition, 120.00 has 5 significant figures since L has 3 trailing zeros. This convention clarifies the precision of such numbers. For example, if measurement is 4 decimal places is given as 12.23, then it might be understood that only 2 decimal places of precision are available, stating the result to be 12.23. Making it clear that it's precise to 4 decimal places in case of 6 significant figures. Could be 1, 2, 3, 4, 5, 6. This brings us back to the question at hand. 7.07 is 3 significant figures because the zero is in the middle. Or you could rewrite it as 7070 meters or 7.07 kilometers. Okay, now that's the end of the first question. E is the points. E is 6, 6. It's the centre of Brown Park. How much shorter is to walk directly from B to C rather than take the path to E and then on to C? So we know what B to C is already. So we know that B to C is from here to here. But what we have to figure out is how far is it to go through the path and out again. So we have to find out 2 different distances this time, okay? So what we're going to do is we're going to find out the distance from B to E and then E to C. So the length of BE, and we can call E x2, y2, and we're going to call B x1, y1. So we're going to get the square root of x2 minus x1, so that's going to be 6 minus 3 squared plus y2 minus y1, 6 minus 10 squared. I'm going to put this directly into the calculator. So what we can get here, so 6 minus 3 squared and 6 minus 10 squared. And we get this as 5. Okay? So the length of BE is 5. Now we've got to find the length of EC. And for this one, we're going to call C x1, y1, so 10 and 9. So we're going to get the length of EC. and the length of EC is going to be the square root of x2 minus x1 squared, so it's going to be 6 minus 10 squared. 6 minus 10 squared plus 6 minus 9 squared. Okay, so once again we're going to put this into the calculator. Quick change around on our figures here. 6 minus 10 squared and 6 minus 9 squared. And this also turns out to be 5. So what we know is that EC and BE are actually the same length. So this one and this one are the same length. Okay. Now, how much shorter is it to walk to B to C? So look, BC and EC added together is 10. But we got to take it, that's 10 kilometers when you add them together. So 5 kilometers plus another 5 kilometers, 10 kilometers. Then we're going to take away the 0.07 kilometers. And what we get here is 10 minus 7.07. And we get here is 2.93 kilometers. Okay, that's that one done. The points A, which is 1, 8.5, and B, 310 are on tangent-tree. Find the equation of tangent-tree. Now, to find the equation of tangent-tree, it's basically looking for the equation of a line. Okay, so we need to write down what equation of a line is. Equation of a line is y minus y1 equals m into x minus x1. We need to know, we're going to call b x1 y1 just because it's whole numbers, and a can be x2 y2. So we know what y1 is, we know what x1 is, but we need to know what the slope is. So we're going to write down the slope formula straight from your table. And what we're going to get here is y2, which is 8.5 minus 10 divided by x2, which is 1 minus 3. Just going to put that directly into the calculator. Just press the fraction button right from the start. 8.5 minus 10 divided by 1 minus 3. And you're going to get 3/4. So we know that the slope is 3/4. Okay. So now that we have the workings for the slope done, all I got to do now is just put my 3/4 for m. That's my 3/4. Now y minus y1 is going to be y minus 10. That's going to be x minus x1, which is going to be x minus 3. Now what we can do is this is divide by 4 on the right, which makes it multiply by 4 on the left. If you don't understand this, a different way of writing it would be to just simply multiply out the top part first, and you're going to get 3x minus 9 divided by 4. Because you have to divide everything by 4 equals y minus 10. Then you can bring the 4 up, so it's going to be 4 into y minus 10 equals 3x minus 9. So then we're going to get 4y minus 40 equals 3x minus 9. You can bring over the 40 over to your side if you want, and what we can get is 4y equals 3x. That turns into plus 40, which makes it plus 31. Or if we want it in a certain way, we could bring these back over to your side, and we could say it's minus 3x plus 4y minus 31 equals 0. Or another way of phrasing it would be 3x minus 4y plus 31 equals 0. All three of those answers are acceptable. Okay. Now we're just going to keep this equation of tangent-tree nice and handy down here. So this is a tangent-tree. So we'll just place it safely in the corner here. Now, next one. Tangent-tree is done. Perpendicular avenue is perpendicular to tangent-tree. and passes through 17, 8. Find its equation. Well, tangent 3 had a slope of 3/4. Okay, so tangent 3 had a slope of 3/4. This means perpendicular avenue must have a slope of -4/3 because it's perpendicular. So we know the slope of perpendicular avenue, and we also know one point on perpendicular avenue. We know 17 and 8, so we can just put directly into the equation of a line. -4/3 into x minus 17. And now we can multiply them out. And what we get is y minus 8 equals -4 by x is -4x, -4 by -17 equals plus 68. And that's all divided by 3. Now, like the last time, we can cross multiply the 3 up, so we get 3 into y minus 8 equals -4x plus 68. And then multiply that out, and we get 3y minus 24. Bring over to 4x plus 4x. Bring over to 68, you get -68 equals 0. Now, move the x to the front. What we get is 4x plus 3y minus 24 minus 68. Minus 92 equals 0. Okay, so that's that one done. The museum is located at the intersection of Tangent Street and Perpendicular Avenue. Find the coordinates of this museum. So basically what it's looking for is the coordinates of basically where two lines hit each other. So we can see the museum is located here, and what in effect it wants me to do is it just wants me to get the intersection of Tangent Street up here and Perpendicular Avenue, which is here, and wants me to find this place here, the museum, the location here. Okay, so it's basically simultaneous equations. So I have 3x minus 4y. I'm going to bring over the 31 over to your side. So 3x minus 4y equals minus 31. I'm going to alter this one as well. So we get 4x plus 3y equals plus 92. Now, what we're going to do here is we're going to multiply the, we're going to pick a letter to get rid of. I'm going to choose to get rid of the y's. To get rid of the y's, the top equation sees, when you look through this window as I call it, the top equation sees a 3, and the bottom equation when I look through sees a 4. That's what the y's see when they look at each other, right? They're looking at the numbers in front of each other. Don't mind the negative signs at the moment. So we're going to multiply everything in here by 3. So what we should get is we're going to get 3 times 3x is 9x, 3 times 4y is minus 12y, 3 times 31 is minus 93, 4 times 4x is 16x, 4 times 3y is 12y, and 4 times 92, we'll just quickly use the calculator for this one, 368. So what's going to happen next is we're going to extend this up, and what we're going to get is 25x. I'm going to add that down, plus 0y equals 398 minus 93. Or sorry, 368 minus 93. And we get is 275. So 25x equals 275. So we divide 275 by 25. So 275 divided by 25. And what we get there is 11. So x equals 11. Now we have to find out what y is. So we know that 4x plus 3y equals 92. We know that x is 11. So 4 times 11 is 44. So 44 plus 3y equals 92. Bring over to 44. 3y equals 92 minus 44. 92 minus 44 is 48. So 3y equals 48. Y therefore is 48 over 3. Y therefore must be 16. So this is the point 11, 16. Okay. So if you look up here, 11, 16 is to the right of 10 and up. So 11, 16 according to your map seems like the right answer. Okay, so you just can check your answer using common knowledge of your map as well. Finally, John is at the town hall and wants to get to the museum. Give one possible route he can take and calculate the total distance he must travel to take that route. So town hall to the museum. So let's see where he is. Rub this out for a minute. Now, the town hall means John is here. Okay. And we know that's 0, 0. So what he can do is he can go over the straight road. So that's, he's travelled 1 so far, because he's gone from here to here, which is 1. So we'll put that down as 1. Plus, now he wants to go from town hall all the way to the town hall all the way to the museum. So he goes up. Now he's going to go all the way up to the start of Tangent Street. So this means he travels directly up 8.5 into the air. So it's going to be 1 plus 8.5. Now he wants to get from this coordinate here. So he wants to get from 1, 8.5, which is located here, to the museum. And we know the museum is located at 11, 16. Okay, so the museum is located at 11, 16. So, and we can find out this distance by using our distance equation. So we're going to find out the distance between these two dots here. So what we can say is that distance, once again, is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so distance therefore equals 11 minus 1 squared plus y2, which is 16 minus 8.5 squared. Okay, square root 11 minus 1 squared plus 16 minus 8.5 close the bracket squared. So you know that this distance is 12.5. Okay, so from here to here is 12.5. So what we're going to get is 1 plus 8.5 plus 12.5. Going to add them all together. And that equals 22. So 22 kilometers for this route. Okay guys, that concludes the end of this video. Have a good summer and hope the summer exam goes well.